Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is, count of full binary trees. Before we move forward, let me introduce myself. Hi, and good evening, everyone. I'm Siddharth Hazra. Currently, I'm an SD mentor at Geeks for Geeks. I'm a candidate master at Code Forces. Okay, so hi Himanshu, hi Nakaj, hi Rishi Chaudhary, hi Anirudh, hi Praveen. So first वाले यहाँ भी आ गए. Okay, fair enough. So I hope you had your dinner, everyone. Okay, for me, the problem statement should be more self-explanatory. Like the problem statement were not helpful to be honest for today. Okay, so I hope my screen is visible. Okay, so just wait a sec. Just wait a sec. I forgot to attach my pen tab. So I would just take a minute.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way.
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Okay, so extremely sorry for the interruption. What happened today was I was traveling from Delhi to my college for the semester exams, and I just got here at around evening. So I was sleeping till around 9 or 10, had my dinner, and just came here. So I forgot. I had the setup ready, but I forgot to have the pen tab. Okay, fair enough. So I think we should move forward. Okay, good advertising technique. What's your journey to become candidate master? So we would talk about all this at the end if you are there. So no, bro. It was just a kind of makeup thing. Okay, fair enough. So let's move forward. Mhm. Open board. Yeah. So I won't read the problem statement. Why? Because the problem statement for me seems a bit confusing and the problem statements are very less to explain the question. Rather, I would explain you the question. So in this problem, you are given an array. Okay. So before we move forward, what is the question? Let us first understand two, three terms. The first one is that a full binary tree. Okay. Now, what is a full binary tree? A full binary tree refers to the tree that is filled at each level. That means that the number of nodes at each level should be complete. Now, what do you mean by complete? What would be the number of nodes at each level? I would tell you. So, before we do that, let's have this kind of thing. Okay. Then it would be more easy to tell you. Okay. So a complete binary tree means that each node would have left as well as the right child. This means a complete binary tree. And I am telling you that the number of nodes at each level should be complete. Now, what do we mean by this? This just means that in the very first level, the number of nodes should be 2 to the power 0. The next should be 2 to the power 1. The next should be 2 to the power 2. The next should be 2 to the power 3. Now, if you count this, you would see that yes, the number of nodes at each level is increasing by the powers of 2. The first one is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Like this. Okay. Am I visible? Yeah. I'm still visible. Okay, this is what it is. So this is known as full binary tree. That the suppose we are at the zeroth level, so it should have two to the power zero. We are at the first level, two to the power one. It should have two to the power two. Okay, fair enough. This is what they are asking for. Now we come back to the problem statement. So in this problem statement, you are given an array. Now this array would contain some elements. Okay, now it is told that you need to make a full binary tree using these elements, and you can use this element more than one. Okay, more than once, like you can use these all elements multiple number of times. Okay, you are given elements and you can use them multiple number of times to build a full binary tree. Now, what are the constraints? The constraint is that the parent, the parent should be the product of its two children. Like this is equal to, suppose this is equal to x and y, then x multiplied by y should be equal to the parent, and this should be true for all the nodes if they have the children. So there are two conditions. The first condition is that it should be a full binary tree. The next condition is this one. ट्रांसलेटिंग द सेम इन हिंदी, यहाँ हमें यह कहा जा रहा है कि हमें एक फुल बाइनरी ट्री बनाना होगा. ओके, जिसमें दो कंडीशंस रहेंगे. पहला है कि ये एक फुल बाइनरी ट्री ही होना चाहिए. दूसरा है कि ये मल्टीपल्स होना चाहिए, मतलब हमें जो एलिमेंट्स दिए गए हैं हम वही एलिमेंट्स यूज कर सकते हैं, और ये भी अलाउड है कि हम वही एलिमेंट्स बार बार यूज कर सकें. Okay, the third one is, okay, third one was not mentioned, I mentioned two, but talking about third one is that the two child that is left multiplied by right should be equal to the parent. Okay, यही हमें पूछा जा रहा. So am I clear with the problem statement or not? Give me a quick one in the chat if I'm clear with the problem statement. Give me a quick one in the chat. Which year you are in? I am in my fourth year currently. Okay, so a few more. Yashraj, Anirudh and all, Himanshu and all. Nakaj, what about you? Okay, Nakaj is done. Okay, fair enough. I think we can move forward. Okay, so this was the question. Now let us observe more. Okay, let us first observe the given sample test case. Okay. So in the given sample test case, so a binary tree can have one node also. So 2, 3, 4, and 6. A single node is also a full binary tree. True. 2, there we can't have two nodes in a binary tree. It is absolutely understood. Then we can have 3. Yes, we can have 3. Okay, so we can have something like this: 6, and then this would have 2, and this would have 3. Okay, this was the very first one. Then the next can be 4, and this can be 2, and we can use again 2. Okay, so 1, 2, 3, 4, 5, and 6. So we are considering one more. Let us see which one are we considering. So 6 can be built by 2 or 3, 4 can be built by 2, 2. Okay, nothing else. So I think we are switching the digits in 6. I think 3 and 2 would be there. Yes, 3 and 2 would be there. Yes, so we are switching the digits one more. So here one more, switching the nodes. Okay, this time the left one is 3 and the right one is 2. Okay, this is the very first example. Do we have more examples? Let us see. Okay, we have some more examples, but the first sample test case was the best one. Okay, so now let us see this. Okay, so see, first we have 2, 4, and 5 itself. In the next one was 4, and the lower elements were 2 and 2 itself. Okay, So how many trees we have? We have 2, 4, 5, and 4, 2, 2. We can't interchange the values because the left one would still be 2 and the left one would still be 2. So interchange of values don't make it a different binary search tree. Okay, full binary tree. Okay, fair enough. So this is what is given. So now if you observe, okay, if you observe this, then you would see a pattern in this. Okay, like if you try to, after you are done with one element, thinking of one element is absolutely easy because this case would persist in every scenario. Okay, be the number be given as 1, be the number given as 100, or be the number given as 10 to the power 5. Each one can be represented as a single element, and a single element is a full binary tree. So it is fine. It is just like a cell, okay, which is the building block of a human body. Okay, and it's fine. Okay, whichever cell, be it the cell of the hand, be it cell of the head, we don't see the difference in it. Okay, but when we try to have the next one, what is the next one? The next set of binary, full binary tree. Okay, the first one is 2. The next one is, of course, 3, because it should have all the values filled, all the levels filled. So 3. Now we are thinking of 3. So whenever we are thinking of 3, we know that this value z, and suppose the parent is z, and this value x and y, and here z is equal to x multiplied by y. We know this. Okay, we know this. So if you observe that I would try to consider z, which is the maximum element. Okay, like the concept of maximum element is coming from here. Like we would come from 6 and we would see, can 6 be made by 2 elements? Yes, 6 can be made by 2 elements, that is 2 and 3. Can 4 be made by 2 elements that is already present? Yes, 4 can be made by 2 and 2. Okay, now the interchange of values, that is 6 can also be made by, let's write it here only so that the intuition is clear. Okay, so we can see that when we try to build the full binary tree of 3 nodes, we try to look for large element, and then we see that can it be done by 2 small elements? Does there exist 2 small elements or not? So the concept of looking from the maximum and going to the minimum, this is there. So this is the intuition, that we would start from the maximum element, and then we would move forward to minimum element, and then we would try to build the binary tree by seeing that if the multiple of it is present or not. Like it is very easy if you just observe it. Okay, if you just observe the general thing, like 6, the multiples of 6 which is present, what are the multiples of 6? Let us write this. Okay, then you would get a proper idea of this. Okay, let's keep this intact. Let us write the multiples of 6. The multiples of 6 are 1, 2, 3, and 6. But when are we moving forward? We are moving forward when we have 2 and 3 already there. Okay, so how do we come across 2 and 3 only, not 2 and 1? So see, it is just like this, that suppose 1 is present. Okay, like 6 is there and 1 is present. So we would divide by 6. 6 divided by 1. So whatever value would be there, that is 6 alone. So if 1 was present, then we could have write 1 and 6 again here, because 6 can be written multiple number of times. Now if we write here 2, so to find the other pair of it, like this is just like this, z is equal to x multiplied by y. If we know z and x, then y is equal to z by x. Okay, this is just like this, y equals to z by x. Same way, if we can see that 2 is present, okay, we know that 6 and this value is 2. So to find the other one, it would be nothing but 6 divided by 2, which is equal to 3. So we know that 3 is the only element that can be put on up here. So we see that if 3 is present or not. Yes, 3 is also present, and we are fine with it. Then we again go to 6. Now we see if 1 is present or not. Okay, So this is just like this, that we start from the maximum element. Then suppose factor 1 is present. Suppose a factor is present of that number. Okay. Suppose a factor is present of that number. Then what we do is we start to look what is the pair of that factor that can fit to this max. So it should be like this, that whatever is coming here, like this value, whatever is coming here, suppose that is, as of now, let us give it a. So we know that f multiplied by a is equals to max. So if a factor is present and max is already known, then a is equals to max by factor, multiplication here, division here. Okay, so a is equals to max by factor. So now we can have a formula from here. So this is just like maximum by factor. Okay, so now we just need to see the maximum element. We see one factor of it. Then the next one would be nothing but maximum by factor, and we need to see if both of them are present or not. And then we need to process accordingly. This was the first set of things. Now, the next set of things. Okay, now suppose, okay, this was the very first thing, okay, that is to be understood. Now the thing is that how would we compute the result collectively? We were, as of now, we are only talking about left and right when the height is only 2. But what about the situation when we have a large full binary tree? Okay, what about that condition? So we would cater that condition too. So that condition would be that, say, like, see, suppose I have here male and a female, and here I have male and a female again. So the pairs, suppose we want two children. Okay, so suppose it is just like this. Okay, like suppose this is team 1. Okay, this is team 2. This is team 1, this is team 2. I want to select two people. Okay, so I can have M from the first team and M from the second team. I can have M from the first team, F from the second team. Okay, I can have M from the first team. Okay, okay, this is very similar. Okay, just wait a sec. Let me just show you. Suppose this is A, B, C, D. Okay, so A can make pair with D, A can make pair with C. In the same manner, B can make pair with C and B can make pair with D. So we see that the number of pairs that we can have is nothing but the number of elements this, that is 2, multiplied by the number of elements here. Okay, so number of elements on the right hand side multiplied by the number of elements on the left hand side would be the number of pairs we can have. Okay, so we can see this. So now what we can do is the number of elements f is bringing and the number of elements mm, max by f is bringing, we would just multiply that value, add it to the max value. We are good with that. That is how this multiplication thing is coming to picture. Am I clear with the explanation? Then we would move to the problem and we would move forward with the implementation, and it would be very clear. The implementation would be such that we would have an array. Why array, not a map? Because we can see the number of elements would be greater than 1 and less than equal to 10 to the power 5. This is the perfect range for an array. So we would use array to check if the f and maximum by f is present or not. Okay, this is it. So when we are computing the maximum, we would also compute the minimum. Why are we computing the minimum? Minimum is not required. We are computing the minimum because it might be a scenario that the maximum element is 200 and the minimum element is just 100. So we don't need to go from 1 to 200. That is why the minimum is also important. To be honest, it doesn't bother us. But if we are iterating on the array to find the maximum, why not have one more comparison and find the minimum so that we can optimize it to a bit more depth? Okay, am I clear with this or not? Then we would just have our answer. Then we would check that if the factors are present or not. If the factors, both the factors are present, that is f and max by f, then we would simply multiply that answer, add it to the value of max answer, and that would be fine. And for the lower values, we would say that everyone would have a value 1 only. Am I clear? Just give me a quick one. Okay, fair enough. I'm clear. Yeah, kind of. We can skip the prime numbers. Yeah, skipping the prime numbers is also an option, but skipping knowing the number is prime or not, we would need to have a prime sieve and all, which would take auxiliary space again. And that is a good optimization, but that won't help much. Okay, so now we would move forward. So I would just yes. So I'm more accustomed to have a in here. Okay. So I hope you are fine with this. Okay. So now what I would do is, here we are told that the answer can be very large. So we just need to have the 10 to the power 9 thing again and again. So I would just declare const int mod is equals to 1e9 plus 7. Is the value that only? Let me just see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 10 to the power 9 plus 7. It is a prime number that is generally used, a large prime number. Okay, the inner meaning of this is just this. Okay, so now we would have long int. Okay, long int max mx is equal to, we can't have max because it is a reserved keyword, then we would just have 0 because we know all the values are greater than 1. Okay, and we have a minimum value. Okay, so we would have mn, which is equal to 1e7, because 1e7, because the numbers are less than equal to 10 to the power 5, so 1e7 is okay. Okay, that 1e7 or 1e5 plus 5 is also good to go. Then we would iterate all the values, okay, to find the maximum as well as the minimum. Minimum is not required, but as we are traversing the whole one for the maximum, why not go and find the minimum also, so that a little bit of more optimization can be done. Mx is equal to max of itself and the value that is already there. Okay, so in the same way, mn is equals to min of itself and the value that is encountered here. Okay, hope it's done. If you want to optimize it further, if something is affecting the maximum, it won't affect the minimum. If something is affecting the minimum, it won't affect the maximum. You can have this condition also, so that we don't do, like, this is a very small question, this is a different question altogether. Okay, so now we would have a vector. Okay, vector int would have here frequency of size. Okay, so we would have mx plus 5, mx plus 5 to be on the safer side. And we would have vector int, and this would store the value. Okay, so val of mx plus 5 again. Okay, and each one would be initialized with the value 0. Each one would be initialized with the value 0. This is the syntax of this meaning. Okay, like you can run a loop and have all the values as equal to 0. So I think, okay, fair enough, we are good to go till this point. Now what we would have, we would, okay, so for now, for int I is equals to 0, just wait a sec. With this frequency array, okay, just wait a sec. Why not do it in one? Okay, so we can have here like this. Okay, and then we would have here as 1e5 plus 5. Okay, why do we do this? So that the frequency can be taken up here only, and we don't need an external loop here. So f of a of I is equal to 1 itself. Okay, and this can also be there. Mhm. Command C, command V, and this was equal to value, na? So we can have a val of 1A5 plus val of A of I is equal to 1 again, and this would be outside equal to 1. Frequency of 1 is equal to 1, and this all together can be done in one array only. Okay, now we would start the iteration. Okay, so we would have for loop for int, so long int I, because we have all the values in here as long int only. Okay, so we would have long int. So we need long int multiple number of times. So I'm just copying it so that I don't need to type it again and again. It is very difficult to write it again and again. I don't want to type. Okay, so we would start with a minimum. Okay, we would start with the minimum value, and then it should be less than equal to the maximum value, and it should be there. So I just told you that we can start from 1 also, 0 also, but as we are already calculating the maximum value, so we would also calculate the minimum value so that the difference can be theirs. But if you don't want to do it, just do it from 1 and it would be fine enough. Okay, now if this value is present, that means frequency of A of I is present. Okay, if it is present, then we would go to its multiples. How we would go to its multiples? Let me just show you. Suppose this value is equals to 5. Then the lower value would be 10, 15, 20, like this. How it is? Suppose this is equal to I. So J would be equal to I plus I. This value is equal to I plus I. This value would be I plus 2I. This value would be I plus 3I. So what we would do here is int j is equal to I. Okay, I 2I. Okay, j is equals to 2I, and j is less than equal to the value mx. First one this, and then the very next one is that after division, okay, after division, j divided by I is less than equal to I, and j plus equals to I. Like j plus I 2I, then I plus 2I, then I plus 3I. That is why we are adding I at each point. Okay. Now, if this particular frequency, that is, if f of j is not there, then we don't do anything. We would simply say continue from this point. That means just skip this part. Okay, just learn about continue if you don't know. If that value is present, then val of j is equals to the value of j added to, okay, value of I multiplied by value of j by I modulo mod. Okay, now the condition is if I is not equal to j divided by I, okay, then value of j is equals to value of j plus, okay, value of I multiplied by value of j divided by I modulo the mod itself, and this is done. Next, before this, after all this is done, we would have the computation of all the values. So we can do it at the end also, but we would do it at this point only. Answer is equals to answer. Okay, like answer is equals to answer plus value of I modulo mod. Okay, and then we would return the answer at this point. Okay, so now let us just compile and see how many errors are we making. This should be 2 multiplied by I before this only. Okay, we have a compilation error, and this should be mx because we have defined mx, not max. Answer was not declared. Okay, so we need to initialize long int answer is equals to 0. Okay, we have a runtime error at this point. Okay, I think if we do this, many a times this happens with geeks or geeks. I don't know this. Okay, so if we have here as mx, if we have here as mx, and then we have the same loop again. Okay, and if we have the max as well as min going out. Now let us see if it is still a segmentation fault. Okay. F was not declared in the scope. F is declared in the scope. How it is saying me? Okay, we need to remove this. Okay, this was not declared in the first one. Compilation error. Okay, segmentation fault. Oh, today we have a lot to do. Long int mx is equals to 0. Max of a of I. Can anyone spot line number 22? It should be. Do you think we need the val array? Okay, just let me block this. Okay, we don't want the private account. Okay, do you think we need the val array? Yes, val array is needed to store the answer. Okay, val array is needed to store the answer. Earlier, it seems that val array is not required, but as you move forward, you will see that the val array is used to store the answer. Then the next line is long. Okay, maybe it starts from the min value and I is less than the maximum value. Okay, and I plus plus for int f of I, and then we have the for int j is equals to 2 into I. J is less than mx and j by I is less than equal to j plus equals to I. Okay, so we would continue at this point. Value of j modified to value of I multiplied by j of I modulo mod. If I is not equal to j of I, then value j. Can anyone spot the issue quickly? Answers, I can answer for them. Like, do we have the issue in this? And long and f dash mx plus 1 long long and val dash mx plus 2. Let's say this 2 mem set. Okay, mem set f comma 0 comma size of f and mem set val comma 0 comma size of val. Okay. Do we have any error over this? Okay, don't know, seems like the server is not responding because it's a correct code. Okay, mod 10 to the power constant, mod 10 to the power 9 plus 7. Yes, that should be good to go. Yes, I think there is some issue. I would mention the issue at the comments section only. Okay, so J online number should be also long and can anyone with access storing in the val array? Okay. Okay, J can be. I don't think that would make. Just let me see. It would have given. Might be the scenario. I missed this step. No, don't know. Tried all possible things. I think I would just have it in the comment section and would mention it. It is a very small mistake. I don't want to keep everyone waiting. Okay, so I hope the concept and the code was clear. I am missing a small case, I think, or the code was not working at this point of time. I am not aware of it. I would quickly debug it and I quickly provide the code in the next 5 minutes, I think so. Okay, so what if we don't give the size of vector? If we don't give the size of vector, then what happens is initially the size is 1. Then if the number of elements you are pushing exceeds 1, then 1 multiplied by 2. Then if you exceed the number of elements put in it more than 2, then it would have 2 multiplied by 2. Like every time you exceed the limit, the size gets doubled. Every time you exceed the limit, the size gets doubled. So it is, to be honest, it is not advisable that you use vector without the size if you already know the size. If you don't know the size, then it's fine, but if you know the size, it is advisable that you move forward with predefined size itself. Okay, so what actually we are storing in the val array? So we are storing something like this, that we are storing the answer for 6. Okay, like for 6 we have 2 and 3. Okay, so we are storing the answer for 6. Now 6 can also contribute to the answer of 36, like 6 and 6 again. So we are storing the answer of each small subpart that is contributing to the top. Okay, this is just like this. J can be I plus I. So 2I and I plus I, that won't make a difference. Still, I would take this concept last time. Okay. Yes, we still have the runtime error. Okay, I would just see to it. So hope I'm clear. I would wait for the next 30 seconds. If I don't get any doubts, I would turn off the session. So any more queries we have in this code itself, you can see the code itself also. Val is like a DP array. Yes, absolutely. It can be visualized like DP thing only. Okay. It is not a medium level question that was mentioned. If you go to the article link of the question, it would be seen that it is an expert level question. Please dry run once. Absolutely, I would dry run this once. So if you can see, so see, this is just like this. Okay, suppose we have 2. The multiples of 2 are 1 and 2 itself. Okay, so we go to 1 is not present, we go to 2, then we see the next pair of 2 that can be clubbed with 2 is 1 only, but 1 is not present, so the answer for 2 is 1. Okay, then we come across 3. So 1 is not there because we are told that the greater than 1, integer greater than 1. Okay, that is why we are considering 1 is not present. So the answer for 3 is also equals to 1. Now suppose 2 and 3 is present, we come across 6. Then we come across the factors of 6. The factors of 6 are 2, 3, 1 and 6. So now see how we are getting the values. Okay, so this is just like this: 2 and the next pair of 2 is 6 divided by 2 is equals to 3, so the 2 can be coupled with 3 to make the value 6. Okay, 2 has a value 1, so 1 multiplied by 1 is equals to 2. Okay, 1 multiplied by 1 is equals to 1. So 6 would have an answer as 1. Then we come across 3. Now 3 can also be coupled with 2 to make the value as 6. So again 1 plus 1 is equals to 2. So for 6 the value is 2, for 2 the value is 1, for 3 the value is 1. So now if we have the values of the integers as 2, 3 and 6, then the answer would be 1 plus 1 plus 2, that is equal to 4. Here, that is why at each step we are adding the answer to it. Okay. Okay. So hope I'm clear till this point. Okay. So I would provide you with the very small error that I'm making after this. Any more queries I have? Okay. Devansh, am I clear with the dry run? Can we use index as well because we are creating array size as the maximum element? Yes, absolutely. You can use index as the val. Yes, a little bit of small optimization can be done. Okay, Devansh, can you quickly confirm if things to you are clear or not? Okay, so that was it from my side. Okay, so I would quickly provide you the error in the comment section only. Okay, good night, everyone.